Hi everyone. In the last video we have discussed arithmetic progression as well as geometric progression. So let us see harmonic progression. So here, as we have discussed in the introductory part, harmonic progression is nothing but it is the reciprocal of the arithmetic progression. So here, if you consider that a1, a2, a3, a1, a2, a3 dot an, if it is in harmonic progression, that means the reciprocal of this, so 1 upon a1, 1 upon a2 dot 1 upon an, that will be in arithmetic progression. So similarly you can take an example. Let us say 1 by 3, 1 by 6, 1 by 9, it is in HP. So obviously 3, 6, 9, it will be in arithmetic progression, or vice versa. If 3, 6, 9 dot they are in AP, then the reciprocal of that will be considered as the harmonic progression. Now here, just to calculate the nth term of the harmonic progression, we use the concept of the arithmetic progression. First we will convert this harmonic progression into arithmetic progression. We will calculate the nth term of that arithmetic progression. We will take the reciprocal of that term, and that becomes the nth term of the harmonic progression. So here, if you consider suppose let us say a1, a2 dot a3, they are in HP, harmonic progression. It means 1 upon a1, 1 upon a2, 1 upon a3, that will be in arithmetic progression. To calculate the nth term of this harmonic progression, we will first calculate the nth term of this arithmetic progression, which we got from the terms of this harmonic progression, is just the reciprocal of this. So nth term of this, can we say that nth term of this, it will be equal to how much? If common difference of this, if it is d, then nth term, that is a plus n minus 1 into d. So a means here it is 1 upon a1, a plus n minus 1 into common difference, this d. And common difference d, it will be equal to how much? 1 upon a2 minus 1 upon a1, 1 upon a3 minus 1 upon a2, and so on, because these terms are in arithmetic progression. So this is the nth term of the corresponding this arithmetic progression, and that is coming as 1 upon a1 plus n minus 1 into this d. Now the nth term of this HP, that will be what? The reciprocal of this. So reciprocal of this, it means how much? 1 upon a1 plus n minus 1 into d, its reciprocal. So here that will be equal to, let us say, nth term of this HP, nth term of HP, that will be equal to how much? 1 upon this an, and that is equal to 1 upon this. So 1 upon a1 plus n minus 1 into this d. So this is the nth term of this HP, which is 1 upon a1, and that is 1 upon this. So this way we calculate the nth term. As far as sum of the terms in the HP is concerned, we don't have any particular relation. As we have sum of nth term in AP, we get how much? If you consider this, we have the relation for nth term, sum of nth term in AP. Similarly, sum of nth term in geometric progression, those relations are already there, and directly using that we can calculate. But we don't have such relation as far as the harmonic progression is concerned. Then depending on the nature of the series, the nature of sequence, we will use different ways to calculate the sum of the terms in the harmonic progression, and there is no need to remember any formula as far as these concepts are concerned. Simply it will completely depend on situation, and observing that situation we will be using different ways to calculate the sum of the terms. Sometimes it may be arithmetic, geometric series, sometimes we will take help of arithmetic progression as well as geometric progression, sometimes we will take help of the sum of series, like it may not be in the arithmetic progression, it may not be in the geometric progression. So there we will use the concept of the summation of the series and all that. So depending on situation, we'll use various ways to calculate the sum of the terms. If some books, some writers says this is the particular relation to calculate sum of nth term of the harmonic progression, there is no need to remember those formulas. And if it is needed, you can easily calculate it. Now let us see. So here also you can see the same thing that we have considered just now. Like you have 1 upon a1, 1 upon a2, dot dot 1 upon a, and is in arithmetic progression. From that we will get the common difference. Either you say nth term minus n minus 1th term, or n minus 1th term minus nth term. That depends whether it is you are taking in the descending form or you are in the ascending form, and that way we can always calculate the nth term of the harmonic progression. Now there is a property which we have also discussed in the arithmetic progression. If you have x is the pth term, y is the qth term, and z is the rth term of harmonic progression, similar kind of relation we have in the arithmetic progression also, then 1 upon x is the pth term. So corresponding to that 1 upon x, 1 upon y, 1 upon z, that will be what in the arithmetic progression. So similar relation we get from the arithmetic progression, the concept of arithmetic progression. So here 1 upon x, 1 upon y, 1 upon z, PQR 1 1 1, that will be equal to 0. So this is nothing but again the same concept that we have used in the arithmetic progression, just by taking the reciprocal of these terms. Now let us see these means, arithmetic means, geometric means, and the harmonic means. So in general we call it as means. Now suppose if you have two numbers, let us say a, b and c are in arithmetic progression. Arithmetic progression. So common difference between these two and these two, it is same, because that is the feature of the arithmetic progression. So here b minus a, it will be equal to your c minus b. So from this you will get twice of b is equal to a plus c. If you bring this b this side, it will be b plus b. We bring a this side, so a plus c. So from this we get a plus c divided by 2. So b is equal to a plus c by 2. It seems that it is the average of a and c, and that's why we call b is the mean of a and c. B is the arithmetic mean, because a, b, c are in AP. So we say b is, in general, b is the mean of a and c. In particular, b is the arithmetic mean of a and c. So here there are three terms. So we have this b as the arithmetic mean between the a and c. So that way we can calculate. Now let us say if there are n number of terms. If suppose you have n number of terms, let us say a1, a2, a3, dot dot an. Okay, then how to calculate the arithmetic means? Or the same thing, it can be considered in different way, that suppose we have two terms a and b. A is the first term and b is the last of any arithmetic series. Clear? Now we want to introduce n number of arithmetic means between a and b. N number of arithmetic means between a and b, means we want to develop a sequence. So let us say the first term, it is a. The first arithmetic mean that we introduce here is suppose a1, then a2, a3, dot dot, suppose this an. So we have introduced n arithmetic means. So once you introduce n arithmetic means, then this sequence, it will be what? In arithmetic progression. A, a1, a2, a3, dot dot, a and b, you can say now it is in arithmetic progression, because all these terms a1, a2, a3, it has been introduced in such a manner that they are the arithmetic means, n arithmetic means between a and b. So that means a1 minus a, a2 minus a1, a3 minus a2, that becomes what? Same, and that will be common difference. So now here what should be the value of that common difference. If we can calculate the value of that common difference, from there we can calculate value of the first arithmetic mean, second arithmetic mean, third arithmetic mean, nth arithmetic mean, and so on. So let us calculate that. Now just to calculate that, a remains same as the first term, but b becomes what? Not the nth term, but it becomes n plus 1th term, because already we have introduced n number of arithmetic means. First term is this becomes your second term, which is a1, third term which is a2, fourth term which is a3. So n becomes an, means what? N plus, so this is nth term, but b becomes what? N plus 2th term. Okay, n plus this 1, so n plus 2th term. First, second, third, fourth, and that becomes your n plus 2th. So b is the n plus 2th term. Already 2 terms were there. N terms have been introduced. So this is now n plus 1th term. Nth arithmetic mean, but n plus 1th term. B becomes what? N plus 2th term. So last term is n plus 2th. So total number of terms now present in this sequence is n plus 2. So B is the last term. So can you say B, it is equal to A plus n minus 1 into D, that is the nth term. So it means it is n plus 2 minus 1 into common difference D, which is equal to your A plus n plus 1 into this D. So from here, can we calculate D is equal to, and this is your B here. B is equal to this is equal to A plus this. So from here, we can calculate B is equal to how much? So D is equal to, from this you can calculate D is equal to this B minus this A. So B minus A divided by n plus 1. So common difference D, it is B minus A upon n plus 1. Once we have calculated the value of this common difference D, now we can calculate the value of any of the arithmetic means. If you have to calculate this first arithmetic mean, we will call it as second term, but first arithmetic mean. Third term, but second arithmetic mean. So A1, that will be how much? A plus D. So A plus this D. A2 is equal to how much? A2, this is second term. So A plus n minus 1 into D, means 2 minus 1 into common difference D. So from there you can calculate the value of this A1, similarly A2, A3 and all that. Now again, there is no need to remember the formula. What will the value of nth arithmetic mean? So there is no need. Once you know the common difference, and this also there is no need to remember, because you know. Simply you have to get into the concept. If we have introduced n number of terms, so first term remains same as A, the last term becomes n plus 2th term, because the total number of terms already present there were 2. N number of terms we have introduced, so that makes it n plus 2. So this last term becomes n plus 2th term. Common difference we have assumed 2. Use the relation for nth term. Simplify, you will get the value of D. Once you calculate D, use any relation of arithmetic progression and calculate whatever is to be calculated. Similarly, we can consider this geometric progression. Now here again, if you consider A and B, 2 terms. Now between these 2 terms A and B, if you introduce again n number of terms, suppose A1, A2, A3 dot dot an, such that now it is in geometric progression. Yani we have taken the value of A1, A2, A3 dot dot an in such a manner that now this sequence is in geometric progression. So again you can say what? A1 upon A, it is equal to R, common ratio R. A2 upon A1 is R, A3 upon A2 R, and so on. Again B is the n plus 2th term. So nth term in geometric progression is what? Nth term an is equal to A R to the power n minus 1, means B is equal to A. B is now n plus 2th term. So B is equal to A R to the power n minus 1. So when R to the power n plus 2 minus 1, because total number of terms here it is n plus 2, B is the n plus 2th term. Nth term is A is equal to how much? Nth term is equal to A R to the power n minus 1. So n plus 2th term, it will be A R to the power n plus 2 minus 1. So simplifying, you will get B is equal to A R to the power n plus 2 minus 1. So it becomes n plus this 1. So here R to the power n plus 1 is equal to b by a. Once you get this relation, from here we can calculate the value of this r, because here r to the power n plus 1, we can arrange it here, you will get the value of this r. Once you get the value of this r, again you can calculate a1 is equal to how much? A into r. A2 is equal to a, this is third term, so a r to the power n minus 1 means 3 minus 1. This is fourth term. So similarly you can calculate and you will get the value of all the geometric means which is introduced between a and b. So we have introduced this a1, a2, a3 dot dot an such that the sequence is in geometric progression. a1, a2, a3 they will be termed as the geometric means. The first geometric mean, second, third, nth and so on. Total number of terms it will be n plus 2. This is second term but the first geometric mean, third term but the second geometric mean, and so on. And similarly we will use the concept of this harmonic progression. Now again, if you consider this a and b two terms, okay, and we introduce again a1, a2, a3 dot dot an such that this sequence is in harmonic progression. Now to simplify, again we will go back to arithmetic progression. It means 1 upon a, 1 upon a1, 1 upon a2 dot dot 1 upon b, it is in AP, arithmetic progression. This is again the n plus 2th term. So it means 1 upon b is equal to 1 upon a plus n minus n plus 2 minus 1 into common difference suppose d dash of this arithmetic progression. Again simplifying, you will get 1 upon b minus 1 upon a is equal to n plus 1 into this d dash, and from this you will get the value of d dash. Once you get this d dash of this arithmetic progression, you can again calculate value of 1 upon a1, 1 upon a2, 1 upon a3 dot dot 1 upon an and so on. Once you get 1 upon a1, a1 is what? Harmonic mean, first harmonic mean. 1 upon a1 is first arithmetic mean. Once we get the value of 1 upon a1, just taking the reciprocal of that, we will get the value of a1. Similarly 1 upon a2, that will give you the value of a2 and so on. So that way we will calculate n harmonic means between these two terms a as well as b. So this way we can calculate it. Similarly, now as we have seen, arithmetic mean between two terms, that was what? B is equal to a plus c by 2. So similarly if you consider a, b, c, and this is in geometric progression, then b by a is equal to what? C by b, and that gives you b square is equal to ac. So from here b is equal to square root of ac. So b is the geometric mean between the two terms a and c. So b, and that gives us b is equal to square root of a into c, because here the ratio is same, so that's why we get this square root sign. So b is equal to square root of ac. Similarly, if you consider A, B, C are in HP, then what will be the harmonic mean of these three? So again this B is the harmonic mean. To calculate the value of B, again we will consider 1 upon A, 1 upon B, 1 upon C is in arithmetic progression. So 1 upon B, that will be equal to how much? 1 upon A plus 1 upon C divided by 2. Because these are in AP. So this plus this upon 2, it will be this. Now again simplifying. So this gives you A plus C upon AC divided by 2, which makes it A plus C upon twice of AC. So 1 upon B is equal to A plus C upon twice of AC, but we need the value of this B. So take the reciprocal, and B is equal to your twice of this AC upon A plus C. So that way we calculate the value of the harmonic mean. So if A, B, C are in HP, the harmonic mean B, it will be twice of AC upon A plus C. If A, B, C are in GP, then B is equal to square root of this AC. And if A, B, C are in AP, then B is equal to A plus C divided by 2. So these are the arithmetic mean, geometric mean and harmonic mean between the three numbers, that is A, B, C and so on. Now, as far as the property, arithmetic mean, if we represent by capital A, geometric by capital G and harmonic by H, then as we have seen the values of arithmetic, geometric and harmonic mean, that is one is b plus c, a plus c by 2, that was twice of ac upon a plus c harmonic, and similarly b is equal to square root of this ac. So if you compare these three means, arithmetic, geometric and harmonic, you will find that a, g and h are in geometric progression. These three means are in geometric progression such that from here again we will get g square is equal to a into h, or this implies g is equal to square root of a into h. So if you form a sequence of arithmetic mean, geometric mean and harmonic mean between the numbers, then they are themselves are in geometric progression, and from there we get g is equal to square root of ah. Second feature is, or property is, that arithmetic mean is always greater than geometric mean, and geometric mean is greater than harmonic means. Means a greater than g and g is greater than h. So this relation we use very frequently. It is used to simplify some of the inequality based questions. So arithmetic mean is greater than geometric mean is greater than harmonic mean. So these are the two relations, two features, and wherever needed we can use it and we can simplify the questions. So we have discussed all these concepts. There is one concept called the summation of series that we will discuss in the next videos, and after that we will start simplifying problems. Thank you.